Good afternoon to every one of you. Today we are going to discuss about stack implementation using array and linked list. So in the previous video I have logically explained how stack works, and in this video we are going to discuss about implementation of stack using array and also linked list. So linked list operations we have already discussed in the previous video implemented program, and here we are going to majorly discuss on array and logical discussion of how stack works with linked list. And for the implementation of linked list with stack, so it is open to all. You people should work in a compiler about how to implement linked list stack with the help of linked list, right? So let's get into our topic, and with the explanation of stack, I'll repeat once again. So stack is nothing but it's a collection of list of items with one end open, rest of the ends are closed. We can perform insert and delete operations at one end of your stack, which is called top of stack, right? So this is called the stack, and we have logically discussed about how to work with stack, what are the major operations of stack. Now we'll discuss about logical explanation for stack operations, right? So I have logically drawn a diagram for stack operation. So first we'll discuss about push, then we'll go for pop. Okay, now first of all push. So push is operation which is nothing but insertion of an element into the stack, right? So as I already said, stack will always have the value of stack initialized with value of -1, right? So stack initially holds the value of -1, and it should be globally declared when you are implementing in your compiler, right? So that every function, pop function, because completely the stack implementation depends purely on the variable called stack. So it should be globally declared so that it can be accessed throughout the program, right? And for performing your push operation, you need to check for whether the stack is full or not, and the vice versa. When you are implementing your pop operation, so you want to check for whether the stack is empty or not. So purely based on the variable called top variable. So as you already said, top is nothing but the important variable that is going to work with stack, right? So whatever the operations, whether you are four major operations of stack, push, pop, easy, empty, and top. So all the four operations purely depends on this top variable. For example, if I am going to perform a push operation, I need to check for whether the stack is full or not. How come we can check for a stack is full or not? If the stack holds, we already said that stack is a static memory allocation. It is of fixed size, right? Let's assume stack size is 5, right? So we are implementing through array. So if stack of 5 is nothing but the fixed size, and the top is initialized with the value of -1, for every inclusion of a variable or every inclusion of an element will increment the value of top by 1, right? So when the top variable reaches the maximum size -1, right? That's maximum size is 5, so maximum size -1 is 4, right? When top variable becomes 4, that means that stack is full, right? So based on the top variable, we can able to assess that whether the stack is full or else empty, right? So in this case of push operation, here we are going to perform with push. So perform push operation. Now I want to check for whether the stack is full or not, because if the stack is full, I cannot able to perform push operation. Push is nothing but inserting of an element into the stack, right? So if what is the condition you need to perform here? So if top equal to, here it should not be like this. So there is a small change here. In this case, top equal to max size -1, right? So here in case of push operation, you need to check for whether the stack is full or not, right? So here it is wrongly specified. So top equal to max size -1. In this case, here also and here also. Here initially it is this is fine. Initially top should be initialized with value of -1, and in this case there is a small correction needs to be done. So it is wrongly specified. Top double equal to max size -1. if top equal to max size minus 1, which means that top almost occupied, that is stack is almost occupied and there is no space for inclusion of a new element. So at that case we can specify in a print statement called stack is full, right? If stack is not full, right? So in such cases we can go for inclusion of any element, right? What needs to be done is, so top should be incremented by 1 and then you can go for keeping your top value as index value and assign the element to the respective position of array, right? So let's go for a logical discussion of how this push operation takes place. And this push of 1 is nothing but the element I want to insert into stack. So initially stack is empty, so top is assigned to the value of minus 1. When I insert 1, top becomes 0, right? As I said here, stack is not full, so it goes to the else part. Here top incremented by 1, so top becomes 0, and stack of top equal to element, so stack of 0 equal to element, which is 1 is assigned. Now in the second push of 2, here top is again incremented by 1 and 2 is inserted, and here again top is incremented by 1 and 3 is inserted, and top is again incremented by 1 and 4 is inserted. Now currently top is holding the value of 3, right? And push of 5, top now holds the value of 4 after incrementation. So when I try for pushing of another value called 6, now top is holding the value of 4, which is nothing but max size minus 1. In this case, here this case will execute, right? Because when I try to perform element number 6, right, what happens? Top is holding the value of max size minus 1. Here in this case, as I said, this needs to be changed. It is wrongly specified. Top double equal to max size minus 1, right? This case will get executed, right? So top is holding max size minus 1. Max size is defined as 5 and 5 minus 1 is 4. So now top equal to 4, so it prints stack is full, right? So this is how push operation needs to be executed in array with the when implementing through array, right? So this is push operation, right? We'll move on to the next one, which is pop operation, right? Pop operation is almost similar, right? Here what you want to check is whether the stack is empty or not, because pop operation is nothing but deleting an element from an array. Here if the stack is empty, I cannot able to perform any element deletion, right? So in this case you need to check for pop stack is empty or not. How this can be done? So purely depends on the variable called top, right? Here when a stack is empty, if the top value is equal to minus 1, then that indirectly means that stack is empty, right? So first you want to check for if top double equal to minus 1. If top double equal to minus 1, we can print that stack is empty, right? And you can say that pop operation cannot be performed, right? If not, right, what needs to be done? Here you need to reduce the value of top by 1, right? So that nothing more, this simple one single statement can able to delete one single element, right? How this can be performed? Let's discuss with logical diagram. Listen, here there is a pop. Let's assume stack is full. 5, 4, 3, 2, 1 is the elements are available in the stack, and top value currently top equal to 4. When I perform a pop operation, pop no need to specify any element, right? Because as I already said, insertion and deletion of stack can be performed at only one end called top, right? And here I need to perform pop operation. So last inserted element will be popped out, and here 5 is nothing but the last inserted element. It needs to be popped out, right? So after pop out, so this top value is reduced by 1, which is 3, right? So in terms of computer world, in terms of computer memory, so there is no concept of deleting, right? So data cannot be deleted. Actually we break the linkage to the data so that it is assumed to be deleted, right? If you break the linkage, here also there is no concept of deleting. 5 cannot be deleted, because all the operations purely depends on the top variable. If top is reduced by 1, what does it mean? By default, it indirectly means that 5 is not in the list, right? So that is what the process done here, that is executed here. So top should be reduced by 1. That's enough. So let's go for another one, pop operation. So top equal to currently 3, and I am trying to perform a pop operation that deletes recently inserted element, and which is nothing but 4. So pop should be reduced by 1, so that top becomes 2. Right now it is pointing to 3. Now again top should be reduced by 1, and again top reduced 1. And when only one element is there in the top, top is pointing to, top is holding the value of 0. Right now I am trying to perform one more pop, so which reduces by 1, and now top becomes -1. And when I try to perform one more pop operation, when top equal to -1, what it says, it executes this condition. Right, if top equal to -1, stack is empty, I cannot able to perform any pop operation. Right, so that is what the concept of pop. Right, when I implement stack implementation using array, this has to be checked off. Right, first one, you need to check for whether the top is -1 or not, so that you can say stack is empty. Otherwise, you need to reduce the variable of top by 1, so that that particular that is the inserted element is not considered in the list of elements in the stack. Right. So, and how print process can be done in case of stack using array. As I said, here you need to check for initially you want to check for whether the top variable is having the value of -1, because if there is no element in that stack, you cannot able to print anything. Right. So stack is empty, you can print stack is empty. Otherwise, let's assume there are 3 elements in the stack, and the top variable is holding the value of 2, and it is currently pointing to 3. Right. Look at, and you need to run a loop. Right, I equal to top, and I greater than or equal to 0, I plus plus, I minus minus. What needs to be done is, you need to run a loop reverse from 3 to 1. Right, in reverse index. Right, so from the position of top, I need to run until 0. Right, I need to reduce the value of I, and you can print stack of I. So if I print stack of I, what happens? So stack of 2 will be printed, stack of 1 will be printed, and stack of 0 will be printed. Right, in this case 3 to 1 will get printed, and when this violation happens, if top equal to -1, it goes beyond 0, under 0, so that loop terminates, and finally it runs 3 to 1 1. Right, this is how it works. Right, and how this stack can be implemented through linked list. Right, first one, this is nothing but the push operation. So okay, before you go for that, we'll discuss in compiler of stack operation, then we'll go for linked list discussion. And first one, as I said here, stack is assigned with the static size of 5. Right, it is a fixed size, that is the maximum size, nothing but 5. Push, pop, and top element is empty. Right, and print, and initially top is assigned with the value of -1. Right, so here main function, choice variable, these are all you are aware of. So it gets a choice, and for choosing which option in the switch case, and look at this is nothing but it executes until user enters 0. Right, so that is what the process is. Let's go for push operation. So yes, this is the push operation. Push is almost similar what I have said. Look at, you want to get the element from the user, and you want to check for whether the top is assigned with value of maximum size -1. Here maximum size is 5, and if it is equal to 4, what does it mean? Stack is full. Right, so that is what maximum size -1. It needs to be, if you generically write it for any specified size, you can say it as maximum size -1. So that is what the condition you need to specify here. Here I have specified 4, statically specified 4, and 5 is the size I have defined. That's why it is maximum size -1. Right, if it is yes, stack is full. If it is not, what needs to be done is top plus plus. You need to increment the value of top, and then you can insert the element in the respective index number of array. Right, stack array. Right, stack is nothing but array name. Right, so this is what push operation is. And next one, move on to the pop operation. So in case of pop, what needs to be done? So you want to check for whether the stack is empty or not. Right, stack is empty or not. So here by checking with minus value -1, you can say it as stack is empty or not. Otherwise, you want to reduce the value of top by 1. right? Nothing more, right? And top element, what does it mean? You want to check for whether the stack is empty or not by checking with top double equal to -1. If it is not, you can go for stack of stack of top. So that is what top element is. Yes, small correction. Yes, stack of top is nothing but it returns the top element, recently inserted element of stack. And is empty, what does it check for? Whether the stack is empty or not, right? By checking with the value of top double equal to -1. If it is holding the value of -1, what does it mean? Its stack is empty, otherwise stack is not empty, right? So this is error-free program, and I can share. And first we will execute this program. So compile, run. Let's have bigger screen. Enter the choice of operation to want to perform. First one, push. Enter the element 1. Yes, continue. Let's make your stack full. So I'll consecutively add the elements into the stack. Yes. 3, 1, 1, 4, 1, 1, 5. I have inserted 5 elements. Yes. Now stack is full. Let's check for one more push. 6 is the stack is full and cannot perform insert operation. So this is what the process is. Right now stack is full. Right now I reduce. I want to pop up the elements. Yes, I want to continue 1, 2. Yes, performing pop operation. So let's go for printing of elements. Right. So 5. So 1, 2, 3, 4, 5. So 5 removed. Now 4, 3, 2, 1 is the elements available. Are the elements available in the stack? Right. Fine. So now I want to completely pop down the stack to 0. Right. No, there should not be any elements in the stack. I want to continue the process. 2, 1, 2, 1, 2. Let's check for elements in the stack. 5. Only one element in the stack. Yes, I want to continue pop. Now there is no element in the stack. Now I try for one more pop up. Now stack is empty and cannot perform pop operation. So now stack is empty. Currently top value is equal to -1. Right. So now let's perform one more push. Let's check for 9. Sorry, 1 push. 9, 1 push, 8, sorry, 1 push, 7. Let's go for printing of elements. 5. Yes, 7, 8, 9. And I want to return the top element, right? Yes, I want to return the top element. So which returns recently inserted element. So 3. What does it return? 7. So 7 is nothing but the recently inserted element in the list, right? Now I want to check for one more operation that is left out, which is empty. So 4 is nothing but the option, and I want to check for whether the stack is. So what does it mean? Stack is not empty. So currently 3 elements are available in the stack, and stack is not empty, right? So this is how stack operation can be implemented using array concept, right? So once I give 0, it exits the loop, right? So this is what the complete operation of stack, right? So you can implement very simple operation, not like linked list. You can easily implement. Just if you have a basic understanding of an array, usually you can be able to work out with how to implement stack operation using array data structure, right? So now we'll discuss how stack can be implemented using linked list, right? Okay. Look at here. This is nothing but the push operation of stack using linked list. So in this case, the same assignment should be done. assume top equal to -1. Look at assume top equal to -1. As I already discussed in the linked list concept always have two informations. One is data, another one is nothing but address of next element. Right here, let's take a logical discussion about how stack can be implemented through linked list. Here I am going to insert. Let's assume stack is empty. I am going to insert one element called 1, and here it consists of two information. One is data element, another one is address part of next element. Initially, all the values are assigned with the value of null in address of next element. Right, since there is no element in the list, and this is going to be the first element in the list. Now top is assigned with the same value, right? So the top is nothing but a simple just normal pointer, right? It's not a structure pointer, right? It's a normal pointer to point to data element of your structure pointer, data element of your node, right? Fine. Now I want to go for the push of second element, right? This push operation is nothing but push operation of stack in case of linked list is almost like insert at last, right? So insert at last is we always perform, because in case of your linked list you have three operations: insert at beginning, insert at last, and insert at middle. So insert at desired position. Here stack operation insertion is not the push operation of stack. Here in case of linked list is works like almost like insert at last. So whatever the elements you are going to insert will be performed only at the last position. So now what needs to be done is push of 2. So here you want to have a head pointer not specified. So head pointer, with the help of head pointer you can insert so you can have one more temporary pointer, and you can with the help of temporary pointer you can make this as null, and by changing the value of address of next element, you can make that first node to point to the second node, and second node's address part can be pointed as null, and for top variable need should be incremented by 1. Alright, and push of 3, similar process. By adding one more element, top becomes 2, right? And push of 4, top becomes 3, and push of 5, top becomes 4. And even though you are making a dynamic memory allocation through malloc, you can have a fixed size, right? Because stack is a fixed size. You can implement through the linked list purely dynamic memory allocation, but here you need to have a fixed size, right? Fixed size in the sense you can go for inclusion of 5 number of elements. Let's assume it's a fixed size, because stack doesn't have a dynamic memory, right? So stack is a static memory allocation. If you are fixing it as 5 number of elements can be performed, yes, 5 is the fixed size, right? So if since top equal to max size -1, push operation cannot be performed, right? Max size -1 is 4. 5, let's assume it is 5. So 5 minus 1 is 4. So since top has reached the value of 4, so here further insertion cannot be done. So this is how in case of linked list, push operation can be performed in stack, right? So let's go for pop operation of linked list. So if you perform pop operation, we need to have our head pointer. As I already said, head pointer is needed. Head pointer always pointing to the first inserted element, heading the element, right? So here you can take a reference of head pointer, right? So you can create a pop pointer, move it to the previous element of the last element in the stack. So from here you want to create a pop pointer here that takes assigns the value of head with the pop pointer, and from here I want to move the pop pointer to because I am going to delete the last inserted element. As I already said, insertion and deletion of stack can be performed only one and, right? So insertion also insertion is similar to insert at last, and deletion is similar to deletion at last, right? So that is what similar operation in linked list, right? So now I want to create a temporary pointer, and I want to move the pointer to the last element to the previous element, right? So to the previous element of last element, right? So now pop pointer is pointing to 2. I want to break the linkage between 2 and 3, and I want to make the address of next part of node number 2 as null, so that 3 will be automatically deleted. So break the linkage between 2 and 3 and using pop pointer, and reduce the value of top by 1. So look at break the linkage between 2 and 3. Now pop pointer should be reduced by 1, so that top is holding the value of 1. So this is how pop can be performed with linked list. right? Pop operation can be performed with linked list. And the print option is almost similar. So we want to have a temporary pointer and make the temporary pointer assigned with value of head, and you take that pointer to the last element, which based on the value of by running a loop with the value of address of next element holding the value of null, and you print from reverse, right? So reverse in the sense from last element to first element, because stack always print as per the order of newly inserted element, right? So from reverse order, right? So from last element to the first element, stack should print, stack want to print the data part alone, right? So that is how print operation can be performed, right? So this is open to you, and you people can implement this in your program. Once you have understood the process of how linked list can be implemented, and once that is done, you can implement stack with the help of linked list also, right? So rest of the things we will discuss in the next video, and thank you so much.